Alright, today's lesson is over weight and balance. There we go. So, our goals. Be able to explain the aircraft's operation, how it's affected by the weight and balance, calculate the weight and balance, and solve aircraft loading problems using weight shift equation. Alright, so we're not going to discuss this. Read it. It should be obvious, right? Alright, so obviously, it's kind of a dumb question. You should definitely care about it. We've all flown on the small airplanes in the simulator, and you can tell what weight does to a plane when it's not balanced. So I am going to play the videos, so let's watch this one. So, maintaining proper weight and balance is critical, obviously. There's always going to be limitations to how much weight you should carry and how things need to be balanced properly to fly safely. So, although weight and balance are two separate things, they're considered together when it comes to flight planning. Hopefully that makes sense. So weight limitations refer to the maximum amount of weight an aircraft can carry. Different weight limitations are set for different phases of flight, including takeoff and landing. So balance limitations refer to the safe range aircraft's center of gravity, range necessary to account for the placement of people and cargo. So obviously the weight and balance change throughout the flight. Just think about the fuel. Be one major thing. Alright, so remember the four forces of flight and the definition of weight within that context. So weight is the force that pulls down toward the center of the earth. It is the opposing force to lift. If weight exceeds lift, an aircraft cannot maintain altitude. So notice the statement that it's surprisingly easy to overload a plane. So most modern aircraft will exceed the maximum allowed takeoff weight if all their seats are filled with fuel tanks full and the cargo compartment is full. So it's something that has to be watched very carefully. And you can think about that question to yourself. So now that you thought about, how you can overload a plane, these are the effects of overloading a plane. It might not take off at all, right? It'll need more space, more speed, and more runway because it's going to need a lot longer to take off. And it won't climb as well, so you might not clear what you need to clear after you've actually gotten off the runway. Alright, so hopefully we understand what balance is. It's the state of physical equilibrium. So, we've all tried to balance stuff. So the point is called the center of gravity, where you find that balancing point. So, it matters how the weight is distributed because that center of gravity might be different in a lot of different applications. Alright, so the center of gravity is the point at which the airplane would balance if it were possibly suspended at that point. So it is the mass center of the airplane, or its theoretical point at which the entire weight of the airplane is assumed to be concentrated. It may be expressed in inches from a reference datum, which is an arbitrary reference point chosen by the manufacturer. So for safe flight, the center of gravity must be maintained within a certain range. So we can see the diagram there. I'll leave this up here for a second so you can pause it. Be a good project for you guys to do at home since we can't do these as a class, but that way you can kind of read it and pause it and try it out if you want. So again, we can't work in small groups, but what kind of problems do you think might arise if you fly outside the center of gravity limits? So I don't feel like just having dead air on here, but hopefully, some of the things you would think about: speed. Your stall speed would probably change because you're changing, how the plane flies through the air, how the pitch tendency of it, and how well the flight controls actually work. But we'll talk more about this later. Alright, so looking at this slide, you can see how the center of gravity that is too far forward can affect the aircraft's balance and limit control authority, particularly with regard to the elevator. And then with insufficient elevator authority, the pilot may not be able to raise or lower the nose enough to perform key functions like takeoff, landing flare, or stall recovery. So here's another slide with just the visual diagram of what we were just talking about. Alright, so calculating the weight and balance condition of your aircraft is a very important fundamental skill that pilots must master. A pilot who attempts to fly an aircraft in an overweight condition or out of balance condition is, setting themselves up for failure. So, just want to read through these and understand the importance, and we also are going to learn how to do some basic calculations. Alright, so we need to talk about a few terms. So we've got center of lift. It's also known as center of pressure. It's the point where lift forces are considered to be concentrated. To maintain balance, the center of lift is located slightly aft behind the center of gravity. So we can kind of see that on the diagram there. So the datum is the point from which all arm measurements are taken. So it's an arbitrary point just chosen by the aircraft manufacturer. Alright, arm or moment arm. The arm is the distance from the datum to any aircraft component or object loaded on the aircraft. So the arm is positive if it is measured after the datum, and negative if it's measured forward of the datum. Station, the location in the plane identified by its arm. The datum is considered to be station 0. An item located at station plus 70 would be located 70 inches aft of the datum. So hopefully that kind of makes sense, but a lot of new terminology. Alright, so we need to understand that a moment is a force that causes rotation. So it's the concept used to determine how various forces interact with each other to achieve balance or to cause rotation. So when the sum of opposing forces equals 0, the system is in balance. So we can kind of see our little diagram there. So notice how to calculate moments. So moment equals the weight times the arm. And our weight's going to be in pounds, and our arms will be in inches, like we had discussed before. So moment is calculated in pounds per inch, since we're multiplying those two together. So if we look at those three weights on that lever, do you guys think that is balanced or not balanced? So I'll give you a minute to do that calculation. Let's see what you come up with. Right? It's just awkward sitting on a video, silence. So, depending on what you did to calculate this, let's start off with the one on the far left. We have 50 pounds at 50 inches. We multiply that together, and again, that's on our negative side. Remember, from our datum point. So those values to the left are negative, and the values to the right are positive. So that would give us a negative 2,500 pounds per inch. We multiply those two together. And then we have our 100-pound weight that's 25 inches from the data, but it's still in the negative position. So we would have 100 times 25 is negative 2,500 pounds an inch again. So now we calculate the one that's on the positive side of the datum, and we would do 100 times 5 or times 50, and we would get 5,000 pounds per inch. So hopefully you realize that if we add those two numbers up, negative 5,000 plus 5,000, that gives us 0. So that tells us that we are in balance. So in a balanced aircraft, the point where the sum of positive moments and negative moments equals 0 is the center of gravity. So we can see the center of gravity is equal to the total moment divided by the total weight. So we've got the steps there to determine this. So we're just going to go through this and we're going to practice it. So we need to determine the arm of each weight in inches from the datum. So we can see that up there already for us. And then we need to determine the moment of each weight by multiplying the arm by the weight, like what we did in the previous example. And then determine the total of all weights and the total of all moments. Then divide the total moment by the total weight to determine the center of gravity. So we need to figure out this right here. Alright, so since I'm not at school and I don't have the smartboard to write on, I tried writing on one of those little like Wacom tablets and I couldn't do it. It just came out too horrible. You barely read it. I'm going to try to talk our way through this. So let's look at item A, the 100 pounds weight. We can see the arm is 50 inches. So that means we're in the positive side, so we have 5,000 pounds inch a moment. And then item B is 100 pounds, and it's 90 inches away. So we would have 90,000 pounds per inch for that item for a moment. And then we would have our last one there, which is 200 pounds. 150 inches is the arm. So we would have 30,000 pounds per inch. So now we could add up all the total weight. We would have, 400 pounds total of all the weights. And our moment is 44,000 pounds per inch if we add up those three that I just talked about. So now we have to divide, according to our formula, 44,000 pounds per inch divided by 400 pounds. And that will give us positive 110 inches center of gravity. So that would tell us that our center of gravity, it's right here, would be 110 inches from our datum point. I hope that makes sense. It'd be way easier to draw it out and talk to you in person, but maybe watch it a couple times or let me know and I'll get some more examples up here. Alright, so I do want you to fill this out. This will be one of the things that you turn in. It'll be student activity 2 in this section. It's just so we know that we're thinking about the terms and what they actually mean. Alright, so for this, I want you guys to be looking at student activity 3 because we're going to attempt just to kind of walk through this together. So make sure you have that out. So you'll see on there that there's two different ways that we can determine load of weight and balance for an aircraft. We can use the computational method or the graphing method there. So hopefully you're looking at that right now. Alright, so read the paragraph there on the first page and notice the handbook gives us a center of gravity range at 10.9 inches to 21.5 inches with a maximum gross weight of 1,320 pounds. So let's flip over to the back there and we can kind of see what we need to do here. So notice we need to list the weight of the aircraft, occupants, fuel, baggage. Then we also need to remember that the fuel is 6 pounds per gallon. So then enter the moment for each item. Remember that's weight times arm. Find the total weight and moment. Then the center of gravity is the total moment divided by the total weight. So I'm going to give you a minute to fill all that stuff out. Alright, so hopefully you got this filled out. So let's go through them. The weight here should be 782. Here we'd have 90, 170, 150, and 110. I'm sorry, just 10 there. So then to calculate the moments, we have to take the weight times the arm. So for a moment here, I got 15,147. This one I got negative 1,710. And I got 2,040. Then I got 6,900 and 680. Leaving me with a total here of 23,057. I can't remember if I said the total over here, but the weight total I got was 1,002. So now we need to calculate the center of gravity by doing total moment divided by total weight. So we do 23,057 divided by 1,202, and we get a center of gravity being 19.1 inches. So let's scroll down a little bit more. Well, that's too far. So is the weight within the limits? Is the center of gravity within the limits? Is it closer or forward of the rear limit? So hopefully we see that our weight limit is under the gross weight of 1,320, and our center of gravity is at 19.1 inches, which is in that limit of 10.9 to 21.5 inches, and it's closer to the rear limit, which means its loading is slightly aft. So now we got, why is the arm for the fuel a negative number? Because it's in front of the datum, right? Hopefully remember that. And we are not going to worry about the graphing one right now, so just want to be able to do that one. Alright, so we just need to read through this and make sure it makes sense. So you may discover that the airplane is loaded within the allowable weight limit but outside the center of gravity limit. So weight can also move and change during the flight as a result of fuel burn, skydiving operations, passengers moving, and luggage moving. So this could alter the center of gravity during flight. So pilots need to know how to shift or remove weight to correct an out-of-limit condition. So here's the weight shift equation that can be used to determine the impact of the shifting weight. So weighted shift divided by total weight is equal to the change in the center of gravity divided by the distance the weight has shifted. So when the weight is shifted from one location to another, the total weight stays the same. Total moments and CG location change. When weight is moved forward, the total moment decreases. When weight is moved aft, the total moment increases. Moment change is directly proportional to the amount of weight being moved. Alright, so I just want you guys to read this and try it, and I'm going to pause this video and pick right back up, so you're going to need to hit pause now to try it on your own. Alright, so hopefully these are the values you got out of this. The weight shifted is 50 pounds, total weight's 2,492 pounds. We don't know the change in the center of gravity, so that's what we're going to be solving for. And the distance shifted is negative 58 inches because it moved forward. So we plug all that stuff in, so we'd have like 50 over 2,492 equals our x, if we want to call it that, the change in the center of gravity over the negative 58. And then we can multiply both sides by the negative 58, and we get a change of center of gravity as being negative 1.16 inches. Make sure that makes sense. So again, as weight is being added or removed, the total weight of the airplane must be recalculated to ensure the aircraft is operating at or below the maximum gross weight. The center of gravity must also then be recalculated to account for the new weight. A new center of gravity will always result when weight is being added or removed. And the allowable center of gravity range may also change.